All right, so we're going to talk today about how to take a function and find its inverse, or how to look at two functions that they give us and decide whether or not they are inverses of each other. So the inverse would be when you take a function and you look at its graph, so you look at the points that make up that line or whatever the graph looks like, and you take those coordinates and you flip their order. And so when you do, it's kind of like a reflection in a way, where you're flipping the x and the y coordinates around. So they're just changing places on the graph. Then you create a new graph, and that's known as the inverse. Now, if you're just given the equation, you're not given coordinates, you can follow these 4 steps to help you find the inverse. Step 1 is to replace the f of x with y. Anytime that you see f of x or g of x or h of x, like we've been seeing in those previous sections, that's a fancy way of talking about y. It's the same as like y equals 2x plus 5, which is something that you guys have seen in the past because that's like slope-intercept form of a line. So anytime you see that, you replace that f of x, the function notation, with a regular y. Step 2 is to take the x and the y, so those variables in your equation, and make them switch places. So you keep all the numbers the same, you keep the symbols the same, you just take your x and your y and you make them change. Then after you've done that, you're going to have to rewrite your equation for y. So you're going to have to get y by itself, and you do that by solving the equation. And then once you have it back in the form like y equals all of the stuff, then you can change that to what we call f prime. So if you look at this piece here that I'm highlighting, there is like a little dash right next to that letter f. That just is like a way for us to note that this is not the original function, this is the inverse of the function. So it's slightly different than the other one. But we can still use f of x, we can still use function notation. They just put that little mark there next to the f so that you know it's the inverse and not the original. Now, if they gave me coordinates like this first example does, like I said, for you guys, if you were given the coordinates and you wanted to find the inverse, you would take all those coordinates and just switch them around. So the inverse of this, when I do 1, 3, that would become 3, 1. I flip them around. So what would the next one say? Okay, 9, 5, and the last one, at 7, 8. Okay, so that would be your new function. Those would be the new coordinates of the inverse. So that was, those are easy. If they give you the coordinates, you just have to flip their order. Now let's take a look at an example where we have to do those 4 steps. Okay, so number 2 says f of x equals 1/5 x plus 4. So I'm just going to follow my steps. Step 1 says to replace f of x with y. So I'm going to now say y equals 1/5 x plus 4. Step 2 is to switch the x and the y. So make those letters change places with each other. So now it's going to say x equals 1/5 y plus 4. Now step 3 up above said solve the new equation for y. So I need to get y by itself. The first thing that I would do is think about when you guys solve equations, like 2-step equations, you always add or subtract first. So I have this 1/5 y, and then it says plus 4. So to get rid of plus 4, I need to subtract it. I'm going to subtract 4 from both sides here. So it's going to say x minus 4 equals 1/5 y. How do I get rid of that 1/5? Multiply by 5. Think about that reciprocal. So I'm going to multiply the right side by 5 and the left side by 5. Because whatever you do to one side, you have to do to the other. So you want to make sure that you're multiplying both of them. Okay, so I'm going to move this up here now because I'm running out of some space. So on the left-hand side, I have this 5 times the x minus 4. So I'm going to think about distributing that 5. So 5 times x, 5 times the minus 4. So that says 5x minus 20. equals y, because 1/5 times 5 is just going to become 1. So that's how we got y by itself. Okay, now that I have y solved for, the last thing I'm going to do, step 4, is replace y with my f prime x. So I'm going to write it back in function notation, but I have to write it just a little bit differently so that the reader knows these are not the same functions. One of them's the original, one of them's the inverse. So f with that little, like that little dash next to it, of x equals 5x minus 20. So this would be the inverse. And I just flipped it around because I like the f of x to come first. All right, so what I want you guys to do is when you look at this next example here, they're asking you to find the inverse, and then they want you to graph it. All I want you guys to do right now is find the inverse of this function. So take that f of x equals 3x plus 15 over 4. I want you guys to try to find the inverse, and then I will talk to you guys about the graph. Okay, so first step is to replace f of x with y. So I did that. Step 2 is to switch your x and your y. So I did that. Now I'm going to solve for y. So the first thing that I would do is get rid of this fraction. Okay, so get rid of that 4. So think of it as like that whole fraction is over 4. So it's like 1 over 4. So the reciprocal would be 4. So I'm just going to multiply both sides by that. That's going to get rid of that fraction for me. So I'm going to have 4x equals 3y plus 15. Now I'm going to subtract 15. So then it says 4x minus 15 equals 3y. To get y by itself, I'm going to divide both sides by 3. And then I'm going to rewrite this. So it says 4x minus 15 divided by 3 equals y. Now if I want to put that back into function notation, so this would be like the step 4, and this up here, it would be f prime of x equals that 4x minus 15 over 3. Okay, so I want to go over what the graphs look like for these. We're not going to be doing a lot of graphing today, but I want to talk about what happens when you graph these two things. Because remember, I said that an inverse is reflecting, and we're reflecting over a specific line, y equals x. That line goes through the origin, has a slope of 1 over 1. So you start at 0, 0, and going up 1 over 1, up 1 over 1, up 1 over 1 forever. That's the line that we're reflecting over. When you're trying to graph something like this, we don't need to make separate XY tables for both of them. We can actually just do one of them, take points that we know will work out nicely, and then when you go to do the inverse, you just flip those coordinates around, like we did for that first example that I went over with you guys today. So I'm going to take a look at this equation here, and I'm going to make an XY table for it. Okay, so I'm going to bring this all over here. So I'm going to solve for x by putting in different values for it, to solve for y, I should say, not x. So I'm going to put in numbers for x here that I know would work nicely. Now you can put any numbers that you want in there, but chances are you might get decimals if you just put in a random number. So what I'm going to do is kind of think about this for a minute. I need to put something inside of x that when I multiply it times 3 and add it to 15, it's going to be divisible by 4. That way I get nice whole numbers. So two numbers that I know work are -5 and +1. Sorry, -1. So -5 times 3 would be -15. -15 plus 15 is 0. 0 divided by anything, so 0 divided by 4 is going to be 0. Now if I put in -1, 3 times -1 would make that -3, plus 15 would give me 12. 12 is divisible by 4, and I get a 3. Okay, so that's for the original one. Now, for the inverse, what I would do then is just take those coordinates that I have up here in this chart and flip them around. So the 0, 3 in the y column, those get moved over into the x column. And then the -5, -1 get moved over to the y column. So now I have a couple of points. All I need is 2 points to graph this because they're linear equations, so they're just lines. Okay, so I'm going to come over here and graph these now. So we have -5, 0, which would be right there on the x-axis, and then you have -1 up 3. Okay, so this would be that first function, f of x. For the second one, I start at 0, -5, so that means I go down 5. And then for the second point, I go right 3 and down 1. Okay, and there's my other line. So this is f prime of x. That's my inverse of the function. So, like I said, there's this line, y equals x. It goes through the origin here, has a slope of 1 over 1. So it looks like that. So that's the line that all of these points get reflected over. So if I were to kind of look at these points on my graphic here, like this one here, that's at -5, 0, and this one that's at 0, -5, that's a reflection of itself because it just flipped those coordinates around. If I look at how they're in relation to this red dotted line I drew in, they're the same distance away from it. They're equally spaced on both sides of that line. The same thing happens with those other 2 points. They're the same distance away from that red dotted line. When you guys work with inverses, we've done the kind of the graphing side before. So you're not going to be doing a lot of this graphing. You're just going to be working with finding the inverses of functions in that. But I just wanted to go over the graph just so that you guys kind of are aware of what that looks like again. All right, now the last thing that we're going to do is look at functions and be able to decide if they're inverses of each other. So you're not finding the inverse, you're just trying to test to see if they are inverses. Two functions are only inverses if, when I do the composition, so when I put one function into the other one, so this is what we were doing in that last section. If I do that, I need to get x to come out both times. If it doesn't come out to be that way, then they're not inverses. So even if it's like x plus 1, or if one of them's x or one of them's negative x, they both have to be positive x in order for them to be inverses of each other. So let me show you an example. I'm given f of x is 2x plus 4, and g of x is 1/2 x minus 4. So I need to do two separate compositions here. The first one is to put f of g. So that means I'm putting g's function into f. Okay, so up here, I'm taking this 1/2 x minus 4, and I'm putting that into f's function. So I'm putting it in for the x in that one. So f says 2x plus 4. So you're going to bring down the 2, and instead of x, you're going to plug in g's function. So I'm going to put that in parentheses. So it says 1/2 x minus 4. Now f also has plus 4 in its function, so I need to make sure I include that plus 4. I'm going to take this 2 on the front of the parenthesis there and distribute. So what's 2 times 1/2? 1. So this would be 1x, or just x. What's 2 times negative 4? Good, negative 8. And then we have plus 4. So negative 8 and positive 4, these are my like terms here. So I'm going to get x minus 4. Okay, now I should be able to tell right away these are not inverses of each other because I didn't get x. I needed to get x as an answer here, and I got x minus 4. If you wanted to just verify for yourself and make sure that you are indeed correct that these are not going to be inverses, you can also then go and do g of x. So this is when we do the opposite of what we just did. Now we're going to take f's function, 2x plus 4, and we're going to put that in for x in g's function. So we're just rearranging the order here. So I'm going to do 1/2, and in for x, I'm going to put 2x plus 4. And then g still has minus 4, so I got to make sure I put that on the end. Now, everything else looks the same so far. Like, I'm going to do my distributive property. So it's going to say x plus 2 minus 4. And positive 2 and negative 4 are like terms, so this is going to say x minus 2. Okay? Again, these are not x. One says x minus 4, the other one says x minus 2. So this tells you that these are not inverses. Okay, so I want you guys to try number 2 on that page. Okay, so here's the work that you should have done. You plug in the other function into it. So for f of g, you take g's function, put it in for x. And for g of f, you go the opposite way. So you put f's into g's. When you do that, when you multiply everything, you get those numbers to cancel each other off. So you do get x on both of them. So these ones are inverses. So I would be able to say that they are. So I'm just looking for like yes, no, or you can write not inverses, yes inverses, just to let me know which one you think it is.